Welcome to Flawless Mathematics. Today I will start a new chapter that is very interesting, that is function. Okay, so basically I will discuss basic concepts today, and if you want to the Bengali version of functions, then I will give you the playlist link of playlist in the description box, so please check the description box and get the link if you want to watch this mapping or functions chapter in Bengali version, right? So let's start today's session. So first of all, what is function, right? So introduction, right? Okay, introduction. So the concept of function is of paramount importance in mathematics and among other disciplines as well, right? So finally, we already knew about in the earlier class, we have already introduced the notation of function, and we have learned about some special function, right? Like identity, okay, identity function, constant function, and Q function, logarithmic function, right, etc. And polynomial, okay, polynomial, one more thing, polynomial function, etc. So we have already introduced the notation and these types of function. So first of all, what is a function, right? So you have to know that there are function about, okay, let me clear my color. Okay, so function recapitulation. Okay, so function as a set of ordered pairs, okay, of ordered pairs. So what it means, function as a set of ordered pairs? That means if you already watched and already watched the relation, the video of relation, then you know that what is empty set and what is non-empty set, because I have already told there, right? So let A and B two empty set, right? It's two, it's not empty, sorry, it's non-empty set. So what is non-empty set? Basically there is if there is no element in that set, so it's empty set, but if there present element, at least one element, okay, so that is called non-empty set. Okay, so let A and B be two non-empty set, and a relation F, right? So a relation F, okay, a relation F from A to B, that is a subset. Okay, there is two condition of being a relation. Number one is the set is have to be non-empty set, and number two is relation is a subset of A cross B, where A and B is two non-empty set. Okay, so that is a subset of A cross B, is called a function. It's called a function from A to B if, okay, there is also condition. Okay, so if number one, that is for each A, what is A here? So A is element that belongs to that A set. So for example, if we write a set A as A comma B comma C, so here A, B, C all are elements of A. Okay, now for each A, that is for every element that belongs to A, right? So here for each A that belongs to A, and that is the symbol of belongs to, that is the symbol. Okay, so for each A belongs to A, there exists B such that every order pair, that is A comma B, is belongs to F, that is function, right? This is the one condition. So let me finish. Okay, see, so function, first of all, okay, there is also another condition. So let me write number 2, that is A comma B belongs to F and A comma C belongs to F, but C is also A, B, C, it's all are elements of A. Okay, so and A comma C, this order pair also belongs to F. Now such that B equals to C. Okay, B equals to C, right? Now we may conclude here that thus a non-void subset. So basically void means empty, or non-void, that is non-empty, right? So non-empty subset of A cross B is a function from A to B. It's from from A to B if each element of A appears in some ordered pair in F, that is in function, and no two ordered pairs in F okay, in F have the same first element. Now there is a term same first element. So there is a term that is image. So it's image. So if A comma B, this order pair belongs to F, then B, okay, B is called the image of A, under F, right? So this is our a very important word, that is image, right? That is image. Okay, so let me summarize this one. Okay, and if you want then you note down also, right? So okay, so first of all it's introduction. So what I told here, that is, so introduction, we already knew about some function, that is identity, consonant, constant function, cube, okay, logarithmic, polynomial, etc. Now there are two types of, if we recapitulate the previous things, then there is a function as a order pair. So what is function as a order pair? Now so A comma B, that is non-empty set, right? So A comma B, this is function as a set of order pair, okay, function as a set of order pairs, right? Now function as a set of order pairs, that is, see here, so if we assume a non-empty set, A and B, two non-empty sets basically. Now a relation F, okay, a relation F. So here functions also a relation, so we denote as relation F from A to B. What is A? So here A and B is non-empty set, and that is a subset of A cross B. I have already discussed what is the condition of being a relation. There is two type of condition. Number one condition, that is it's mandatory that the two sets involving in relation have to be non-empty set, okay, and number two is that relation is a subset, okay, subset of A cross B, where A and B are given set, subset, okay, subset. Now here subset. Okay, now here there is also two condition for being a function. So I already wrote down. So number one condition, that is for each a belongs to a, that is for every element, there exists b such that the order pair, for example, if a set 1 2 3, now one element, right, a is belongs to a. Now there exists a order pair that also, okay, for each element 2 that belongs to f. Okay, as for example. And number 2 is if a comma b, this order pair belongs to f, and also a comma c, this order pair also belongs to f. Now it is mandatory that b equals to c. Okay, it is mandatory that b equals to c. Now we may conclude that here that thus a non-void subset of a cross b is a function from a to b if each element appears of a in some order pair in f, right? It is very clear, I hope. Okay, now there is a big term, that is image. Okay, image. So what is image here? Now if you consider this order pair, right? So what is image basically? So here, okay, let me go to the example. Okay, this example, see the example. So here a comma b, if a comma b is the order pair, so that belongs to f. Now here this also written this order pair a comma 2 is belongs to f. Now we may write it as, okay, here that b, that is the second element, right? So it's 2, okay, 2 is image of 1, because 2 is the second element and 2 is image of 1 under f, that is under that function, right, under that function. So it's a big term, image. Okay, I hope up to this, as far as I said, it's clear to all of you. Now let's move forward. The next type, function as a correspondence, right? Okay, so if you want, then you will note down this. Okay, now move forward. The next, that is function function as a function as a correspondence, right? So what it means? Okay, function is a correspondence. Okay, now the term correspondence are basically synonym for function, right? This term, so this term correspondence, this is terms such as map or mapping, right? And correspondence is basically, they all are synonyms of synonyms. Okay, synonyms for function, right? Basically they all are synonyms for function. Okay, now it's synonyms. Okay, synonyms. Okay, so there is also two condition. What is the condition here? First of all, let a and b two non-empty sets, then a function a from set a to set b is a rule of method or correspondence which associated elements of set a to set b such that number 1. So what is the condition? So before that, okay, so there are also two non-empty set, that is a comma b, and a function, then a function from f if, that is from set A to set B, and in is a rule or method or correspondence which associated elements of A to set of elements of B such that number 1, all elements, right, all elements of set A all elements of set A are associated to elements in set B, right, in set B. So all elements of set A are associated to elements in set B. It is very clear. Okay, now what is our second condition? So our second condition that is an element, okay, or one element, okay, of set A is associated to a unique element in set B, right, unique element in set B. That is the two condition. Okay, so in other words, a function if from A set to set B associated each element of set A to a unique element of set B. If we merge these two condition in one, then in other words we may say that a function if from A set to set B associated each element of set A to a unique element of set B, right. So we write it A, then A to B or A to B, which is read as if is a function from A to B or if maps A to B, okay, if maps A to B. Okay, so which is read as if is a function from A to B or if maps A to B, right. Okay, so and what is about image? That is big word, right. So let's write here. So here and same thing. So there is also a term that is pre-image. So if, okay, I must write here very clearly. Okay, so if it's highlighted, okay, mark highlighted, okay, so it's if an element A belongs to A is associated to an element B that belongs to B set, right. It's capital A set belongs to capital A set and it's capital B set, then B is called what is the if image or only image, you can say also, okay, the if image of or only image, okay, the if image of A or image of A, okay, or one more thing, that is the value the value of the function if at a. Okay, and A is called pre-image, the pre-image of B under the function if, right? So we write it as B equals to f of A. It's very, very, very important. Okay. Okay, it's very, very important. Okay, so A is called pre-image of B and B is called image of A, or the value of function f at A, and or the f image, in another words, the f image of A. Okay, so that's all for today. I hope it's all clear to you, and if there is any doubt, then let me know in the comment box. Okay, so that's all for today. Okay, take care, bye bye.